Well, 3 actually. But I want you to remember the derivative expressions of this. The derivative of f of x equal to square root of x is f prime of x is 1 over 2 square root of x. Let's do a problem that needs the application of the derivative. Find the equation of the tangent of f of x equal to square root of x at x equal to 1. Find the equation of the tangent line at x equal to 1 of the graph of f of x equal to square root of x. Now, in order to find the equation of a line, what are the information that you need? You need the slope of the line and a point through which the line passes. Now, can you obtain the slope of a tangent line? What is the slope of a tangent line at x equal to 1? The slope of a tangent line at a particular point is called the derivative of the function at that point. So what we need to do is find the derivative of this at x equal to 1. There I have the graph of square root of x. And at x equal to 1, I have drawn a tangent line, and that gives me the slope of the tangent line is 0.5. Let's see if that is correct. You know that the derivative of f of x equal to square root of x is f prime of x is 1 over 2 square root of x. We want to find the derivative at x equal to 1. So, what is f prime of 1? Is 1 over 2 square root 1 equal to 1/2. The derivative of this function at x equal to 1 is 0.5. Now look at this. The graph of square root of x. The tangent line drawn at x equal to 0.5 has a slope of 0.5. The slope of the tangent line drawn at that point is a measure of the derivative of the function at that point. Is that right? So the slope of the tangent line is 1/2, and the point is x equal to 1. When x equal to 1, what is the value of the output y? F of 1 equal to 1. That means this point is x equal to 1, y equal to 1. That's right. So the point of tangency is 1, 1. Did you understand the meaning of that? The point of tangency is 1, 1. This point corresponds to x equal to 1, y equal to 1, and that is where we have drawn the tangent line. And the slope of that tangent line is 1/2. Can you now write the equation of the line? The equation of the line passing through the point x1, y1 and having a slope m is, how many of you can tell me the equation of a line that has a slope m and passing through the point x1, y1? Is y minus y1 equal to m times x minus x1. We know x1 is 1, y1 is 1, and m is 1/2. There you go. So y minus 1, that's your x1, y1, and that's your m value. Y minus 1 equal to 1/2 times x minus 1, and take the 1 to the right hand side. We get y equal to 1/2 of x minus 1 plus 1. Distribute that 1/2. That will be 1/2 x minus 1/2, or that will simplify to y equal to 1/2 x plus 1/2. And this is the equation of the line. And this is the equation that we saw in the graph that I produced in the previous slide. Okay. A question for you. Is there a point in the domain of the function where the derivative is undefined? If you take a function like f of x equal to square root of x, is the derivative of that function defined in its entire domain? Now what does that mean? Let me see if I can illustrate that for you. Now, if you recognize, this is the graph of y equal to square root of x. Now remember, derivative is the slope of the tangent line drawn at a point. The derivative at this point, at this x value, is the slope of the tangent line at this point. Let me draw some tangent line for you. Now, if I take, say, x1 here, the derivative at x1 will be the slope of that tangent line. Is that right? The derivative at x2 will be the slope of this tangent line. Now tell me, what is the derivative at x equal to 0? What is the derivative of this function at x equal to 0? What will be the tangent line here? You can see the tangent line is actually the y-axis. It is a vertical line. What is the slope of a vertical line? The slope of a vertical line is undefined. Is that right? Therefore, the slope of the graph of y equal to square root of x at x equal to 0 is a vertical line. That means the derivative of this function is not defined at x equal to 0. Well, you can also say that the derivative f prime of x equal to 1 over 2 square root of x. And because that x is the denominator, at x equal to 0, the derivative is undefined. So, in the case of f of x equal to square root of x, when x equal to 0, the derivative is undefined. Now, there are similar cases. Let's also look at a couple of other cases where the derivative is undefined at certain points. All right? All right. Now, I want you to look at this diagram. Now, what is the derivative? If you can see my pointer, when it goes into the dark area, you will not be able to see it. But you see the point here? At that point, there is the graph of the function has a, we say, it is not smooth. Is that right? The curve is not smooth. That means at this point you can have two distinct tangent lines. Now, let me see if I can actually illustrate that by drawing another diagram. Now, this is how this point looked like. If you have in the graph of a function a sharp turn like this, now a tangent line at this point can be like this or like this. That means there can be more than one tangent line at one point. Now, if you have more than one tangent line at a point, can you talk about the rate of change at that point? Does the rate of change has a fixed value there? No. Therefore, we say if the graph of a function has such a sharp turn, then the derivative at that point is undefined. Why it is undefined? Because it can have a tangent line like this and also a tangent line like that. And the slope of those two tangent lines are different, isn't it? Yes. Now, the slope of the tangent line here will be different from the slope over there. So you've got two tangent lines at the same point and they have different slopes. Therefore, we say the slope of the tangent line at this point is undefined. That's right. Okay. So for the graph shown on the right, two tangent lines are possible at x equal to 0.6. That means the derivative at that point is undefined. The derivative of a function is undefined at points where the graph of the function is not smooth. Okay, how about here? you got a similar situation I just illustrated earlier. You can see the tangent line corresponding to x equal to, what is this? What x value is this? 0.5? Now, the tangent line is vertical. What is the slope of a vertical tangent line? So at x equal to 0, the tangent line is vertical and the slope of a vertical line is undefined. So at points where the graph of a function has a sharp turn or the graph of a function has a vertical tangent line, the derivative is undefined. Alright, now I have drawn some cases where the derivative is undefined. How about this function? You notice here there is a break in the function graph. So the derivative is undefined at x equal to 2. This is x equal to 0, 1, 2. Because the function is not continuous there. There's a break in the function graph there. So where the function has a break, the derivative is undefined. The second case, the function is undefined, is here. We just talked about it, where the function curve is not smooth. You have a sharp turn there. The derivative is undefined at x equal to 3 and x equal to -3 because two tangent lines are possible at these 2 points. That means there is no definite value of the derivative at these 2 points. Another instant where the derivative is undefined is if you take a point on the graph here, the tangent line is vertical and that means the derivative is undefined. So the derivative is undefined at x equal to 0 because the tangent line is vertical at that point. Now we have just laid the foundation for finding the derivative of a function. I want you to understand the meaning of derivative and the fundamental idea of the limiting value of delta y by delta x as the basic definition of the derivative of a function. Now in the next lesson we will develop better methods of using mathematical formulae to find the derivative of functions. In the meantime, I will ask you the derivative of at least the 2 functions we talked about in this lesson. All right?